Mining operation generate tailings as a byproduct of mineral processing. If not properly monitored, tailings storage can create environmental and safety risks. At the same time, tailings contain valuable materials such as silica, alumina, and iron oxide, which can be reused for sustainable brick production. Therefore, an effective monitoring system is needed to ensure both safety and resource utilization. Managing mining tailings remains a major challenge due to environmental risks and limited monitoring system. Traditional methods are time-consuming and may not provide real-time data. The suitability of tailings for brick production is also not always assessed properly. Therefore, a smart monitoring system is needed to monitor condition, classify risks, and support sustainable brick production.
So our group project is about smart tailing monitoring system development for brick production. So our project objective is to develop a smart tailing monitoring system capable of providing real-time data analysis and monitoring to monitor important environmental parameters such as water level and potential contamination risks in order to improve environmental safety. And then the other one is to analyze the chemical composition of mining tailing system using available data set or simulated data for accurate assessment. To identify the safety level of tailing based on predefined environmental and chemical threshold. And then the second last is to evaluate the suitability of tailing for sustainable brick production as an alternative construction material.
Proposed solution. The proposed smart tailing monitoring system indicate water level monitoring, system composition analysis, and decision-making system to support sustainable brick production. Key for the real-time water level monitoring, chemical composition assessment, risk clarification, suitability evaluation for brick production, decision support for sustainable tailing management.
The smart tailing monitoring system integrate water level monitoring, chemical analysis, and decision making to support sustainable brick production. First, water level monitoring. Water level monitoring ialah monitoring tailing water level and classify condition as normal, warning, and danger. Second is chemical composition monitoring to analyze key components such as the silica, alumina, iron oxide to assess the brick production. Third is decision making system to combine the monitoring data to determine whether the tailing to suitable and to unsuitable for brick manufacture. The system supports the brick production and produce by ensuring only safe and suitable tailing are reduced, promoting suitable waste management and reduction in environmental impact. That's all.
This slide presents the Smart Tailings Monitoring Systems application developed for this project. The application was designed to provide an efficient and user-friendly platform for monitoring mining tailings and evaluating their suitability for sustainable brick production. The system integrates several key functions, including water level monitoring, chemical composition analysis, and a decision-making module. Through these features, users can easily access important information related to tailings conditions and environmental risks. The application allows monitoring data to be displayed in a clear, organized manner, helping users understand the current status of the tailings storage area. In addition, the system analyzed the chemical compositions of tailings, focusing on important components such as silica, alumina, and iron oxide, which influence the suitability of tailings as a raw material for brick manufacturing. Based on the collected information, the applications automatically evaluates the conditions of the tailings and provides recommendations regarding their suitability for sustainable brick production. Overall, the application serves as a smart monitoring platform that supports safer waste management practice, improves resource utilization, and contributes to environmental sustainability.
This video shows the coding and development process of the system. The program was developed to process input data, perform analysis, clarify risk level, and generate the recommendation regarding the suitability of tailing for brick production. Analytical demonstration. Develop a Python-based application for brick production and analysis using wastewater material. Input parameter including SiO2, Al2O3, Fe2O3, pH, temperature, moisture content, and water level. The system process the evaluated material composition to determine suitable for brick manufacturing. Automated analysis provided faster decision making and reduced dependency on extensive manual testing. Results are presented through an interactive dashboard for easy monitoring and assessment.
Next is result explanation. First, model performance evaluation. The application successfully processed the input dataset and generate prediction result. Decision tree and logistic regression model achieved 93.3% accuracy, showing good reliability and analyzing the given data. Second, data analysis output. The dashboard displays key indicators including total sample, suitability level, and sustainability score. The generic result provides a clear overview of the analyzed condition based on selected parameter. Next is visualization analysis. Graphical outputs such as trend graph and distribution chart were used to identify pattern and variation within the dataset. Next is engineering significance. The development system convert raw data into meaningful information for faster evaluation. So the result demonstrate the potential of the application as a decision support tool for technical assessment. Next, we proceed to technical reasoning. First, smart monitoring approach. The development system applies data analysis and machine learning techniques to overcome limitation of conventional tailings monitoring methods. Second, model selection justification. Machine learning models such as decision tree and logistic regression were selected due to their capability to identify patterns and classify tailings conditions based on input data. Next, result interpretation. The generate Prediction result and performance indicator demonstrate the ability of the system to classify tailings condition and support decision making. Lastly, sustainable application. The analysis support the evaluation of tailing potential for use in brick production by considering important mineral characteristics.
I will be explaining about feasibility. So first we have technical feasibility. The proposed system is technically feasible as it integrates data analysis and machine learning techniques to monitor tailings conditions. The use of decision tree classifier and logistic regression enables automated classification and prediction based on input parameters. The system can reduce dependency on manual monitoring by providing faster and more consistent analysis. Next, we have operational feasibility. The developed application provides a user-friendly platform to visualize monitoring results and evaluate tailings suitability. The system can also support engineers and operators in making informed decisions regarding tailings management. Lastly, we have sustainability feasibility. The system supports sustainable mining practice by evaluating the potential reuse of tailings materials in brick production. Proper assessment of tailings and characteristics can reduce waste accumulation and promote resource recovery. So, in conclusion, our project has successfully developed a smart monitoring system capable of analyzing tailings conditions and evaluating their suitability for sustainable applications. The implementation of machine learning models demonstrates the potential to improve monitoring efficiency and decision making in tailings management. The result shows that the system can provide valuable information for safer tailings handling while supporting the utilization of mining waste as a secondary resource. For future improvement, we can include larger datasets and real-time field data integration to enhance system reliability. Thank you.
For brick production. So, kita orang terpantau tailings itu, and then dia sesuai tak kalau kita orang jadikan brick. Okay, so
apa tailing? Tailing. Tailing itu bukan ekor kan? Tailing ekor kan? Masih ada. Kita sebenarnya